Having discussed evaluation of eigenvalues and eigenvectors and their properties, naturally a few questions might arise in your mind like why cannot we write zero vector as an eigenvector? What is the geometrical meaning of eigenvector? How can you distinguish between a vector which is not an eigenvector and an eigenvector? Can all non-zero vectors be eigenvectors? What is the meaning of the word eigen? What are the applications of eigenvectors and eigenvalues? This video might help you to answer all these questions. Let's discuss a few examples. Consider a 2 by 2 matrix A and a column matrix 1, 1. By matrix multiplication, you can evaluate AX1 as column matrix 3, 6. When you try to plot x1 and AX1 graphically, you see that AX1 differs from the original vector x1 in two properties. AX1 is a stretched form of original vector and it has also undergone a rotation. If you consider another column matrix 1, 2 and multiply it to the same 2 by 2 matrix A, when you evaluate AX2, you get the column matrix 5, 10. When you try to plot x2 and AX2 graphically, you see that these two vectors are lying on the same straight line. You can verify this mathematically because 5, 10 can be expressed as a scalar multiple of original vector 1, 2. So you can write AX2 equal to 5x2 in this context. Whenever you have an equation of the form AX2 equal to lambda x2, you can get the characteristic equation as well. Here 5 can be considered as the eigenvalue and x2 is the original vector which has undergone a stretching, and this is known as the eigenvector. Suppose you had taken a zero vector here, you cannot make a study on the stretching or scaling. With whichever matrix you multiply a zero vector, the answer will be 0. So there is no possibility of study of scaling or stretching in that context. When a vector undergoes pure scaling or stretching without any rotation, in that context only, we can talk about eigenvalues, eigenvectors and characteristic equation. This scalar multiple is actually the stretching ratio or scaling component of original vector. How far it got stretched or how much elongated it became after the multiplication with the square matrix. That is the idea given by the eigenvalue, and which is the vector that got scaled. The original vector will be given the name eigenvector. The word meaning of eigen is characteristic and it has been taken from German language. Eigenvalue is actually giving us the characteristic of how far the original eigenvector got scaled. If you get a negative eigenvalue, the resultant answer will be a shorter vector. If you get a positive eigenvalue, then the resultant will be a stretched or elongated vector on the same straight line. If you look at another example, a square matrix, a column matrix, when multiplied, you get another vector. You try to evaluate the geometrical locations, the original vector and the resultant vector after multiplication. When compared, you can see that the original vector got stretched and rotated. So here you cannot write the resultant vector as a scalar multiple of original vector. So in this context, you cannot write any equation like ax equal to lambda x, and hence we cannot make a study on eigenvalues and eigenvectors in this context. But if you replace x1 by another column vector x2 equal to 0, 1 and multiply it to the same matrix A, you get the resultant as another column vector 0, 2. When you try to plot it graphically, you see that they lie on the same straight line. x2 and ax2 lie on the same straight line. Can also be mathematically verified because 0, 2 can be expressed as 2 times the original vector x2. So here it involves only pure scaling. So we can write ax2 is equal to 2 times x2 and a minus 2I into x2 equal to 0 will be the characteristic equation. Only when there is pure scaling, we can talk about eigenvalue, eigenvectors and characteristic equation. In the other case, which involves rotation, we cannot even write ax1 as a scalar multiple of original vector. Now, regarding the practical application of eigenvalues and eigenvectors, this has much significance in the field of data science or material science. Also, in construction of shafts in automobiles, the concept of eigenvalues and eigenvectors is used, which is based on scaling. Thank you all.